Today we discuss about an important chapter that is for Germans, that is work, energy and power. So it's a very important chapter in Germans, and it is also a very easy chapter. So here in this first problem, a block of mass small m laying on a smooth horizontal surface attached to a spring of negligible mass. Here spring is very less mass, it is negligible. Of spring constants is K. The other end of the spring is fixed as shown in the figure. So here other end is attached to some mass of the block M. It is at rest position in equilibrium. So now a constant force acting on the block F, it is pulled with a constant force F. Then you can find out maximum speed. So you can find out the maximum speed of the block. Maximum speed of the block. Okay. So now we can solve this problem. Once again, I draw the diagram. So you solve this problem. So here there is a rigid support. There is a smooth horizontal surface. One end of the spring is attached to the rigid support. Other end is attached to the a block of mass small m. Now a constant force is acting on the block in forward direction. Okay, so now you can find out the speed, maximum speed of the block. So this one. So in this case, force constant F equal to K into X. Force constant of this spring equal to F equal to Kx. Here X is the elongation of the spring. So therefore X equal to F by K. X equal to F by K. So now you can find out the maximum speed of the block now by using according to law of conservation of energy. Law of conservation of energy. So that is total work done. Total work done is equal to, that means total work done equal to change in kinetic energy. Change in kinetic energy. So it is also law of conservation of energy. It is also called as, that means according to work energy theorem, it is also work done equal to change in kinetic energy. So in this situation, work done means there are two work dones are there. That means one work done is work done by the constant force plus another work done is work done by the spring force is equal to change in kinetic energy means final kinetic energy minus initial kinetic energy. So when the block is at rest position at equilibrium, that is beginning condition, so its initial kinetic energy is 0. So here work done by the constant force, you know that W equal to F into S. So here F into S means displacement, that means elongation. So plus means here constant force acting on the block in this direction, but spring force acting in opposite direction minus kx. But work done of the spring force is equal to half kx square. So here it is opposite direction of the force, that means minus half kx square is equal to final kinetic energy means half mv square. Of mv squared. Okay, so now So here this x is substituted in the equation. F into x means f by k into minus of k x square. X means f by k whole square is equal to final kinetic energy of m square. Here m is the mass of the block, v is the velocity of the speed or velocity of the block. So therefore f square by k minus kf square by 2k square is equal to half mv square. Now so here k cancel, so therefore 1 by k is common, so therefore f square minus f square by here 1 by k is common, so therefore here 2 into, so that means simply 2 f square by 2 equal to half mv square. So therefore 1 by k into 2f square minus f square means simply f square by 2. So 2f square minus f square means f square by 2 is equal to 1 by 2 mv square. So here this 2 cancel. Why? Because see, it is shifted to in LHS, it is numerator. So this 2 cancel. That means half mv square equal to 1 by k into f square. So therefore mv square equal to f square by k. So therefore v square equal to f square by mk. So now you can find out the v. So v equal to f by root mk. So this is the maximum speed of the block when the constant force acting on the block. Now second problem. A force acts on a 2 kg object so that its position is given a function of time as x equal to 3t square plus 5. What is the work done? This force in first 5 seconds. So now you can find out the work. So now solve this question. So here given data, mass of the block is 2 kg, its time is 5 seconds and its displacement in terms of function of time x equal to 3t square plus 5. So now in this problem we can find out the velocity. So velocity equal to dx by dt. So that means differentiate with respect to time in the above displacement, above position or anyone. So d by dt of x means 3t square plus 5. So v equal to, that means 6t plus 0. Why? Because d by dt of 5 is a constant. D by dt of constant is 0. So therefore v equal to 60, simple 60. So according to work energy theorem, according to work energy theorem, W equal to change in kinetic energy. W equal to change in kinetic energy. So here V equal to 60. Now t equal to 0 seconds. Its velocity is 6 into t. That means 0. It is 0. So here at initial time its velocity of the block is 0. Now t equal to 5 seconds. That is after 5 seconds. Final time. Its velocity v equal to 6 into t. That means here t is 5. So 6 into 5, that is 30 meter per second. So in this situation, W equal to final kinetic energy minus initial kinetic energy. In this case, initial velocity is V equal to 0. So initial kinetic energy 0. So therefore work done equal to final kinetic energy means of mv square of m. Here mass of the block is 2. Here V is the 30 square, V square. So in this case 2 cancel, 30 square means 30 into 30, that is 900. It's a work done 900 joules is the answer. Now problem number 3. A block of mass m is kept on a platform which starts rest with constant acceleration g by 2 upwards. As shown in the figure, the work done by normal reaction on block in time. So this is the diagram. So here acceleration of the block in upward direction a equal to g by 2. So here arrow is in upwards, the acceleration of the block is in upward direction. So now you can solve this problem. Once again I'll draw the diagram also. This is the horizontal surface. Some mass of the block is laying on the horizontal surface. Now acceleration of the block in upward direction equal to g by 2. So now in this block, two forces acting on the block. One force is weight, vertically downward direction, normal reaction, vertically upward direction. So now the resultant force acting on the block by free body diagram of mass of the block, the resultant force acting on the block Fr equal to n minus mg. Why? Because here resultant force acting on upward direction. So here normal reaction is greater than weight of the block. So therefore Fr equal to n minus mg. So now Fr equal, according to Newton's second law, equal to ma. M into a equal to n minus mg. So here acceleration is g by 2. So m into g by 2 is equal to n minus mg. Now normal reaction n equal to this one mg by 2 plus mg. So this minus mg is shifted to LHS, it's a plus. So n equal to 2 mg plus mg, that is 3 mg by 2. So this is the normal reaction acting on the block. Now we can find out the displacement. So now S equal to, using the equation ut plus of at square. So here when the block is initially at rest, so here initial velocity u equal to 0. So therefore S equal to 0 plus of a, here a is the g by 2, acceleration of the block g by 2 into t square. So S equal to g t square by 4. So this is the displacement. So now you can find out the work done. You know that definition of work done equal to F into S. So here this force, that is normal reaction, is the force. So therefore W equal to F means N into S. So W equal to, here N is 3 mg by 2 into, here S is g t square by 4. So therefore W equal to 3 M G into G, G square P square by 4 into 2, 8. So this is the work